Welcome to the deep dive. Today we're digging into a technique that's really becoming central for improving large language models, especially in real-world applications. Retrieval-Augmented Generation, or RE.
That's right. It's something anyone working in ML, data science, or related tech fields really needs to get a handle on. It's all about making these AI systems more reliable, more factual.
Exactly. We've gone through a pretty comprehensive survey paper that lays out how RE has evolved, its core parts, how to evaluate it, and where it's going.
And our goal today is basically to pull out the must-know insights from that survey for professionals listening, give you a solid understanding without getting totally lost in the weeds of academic papers.
Yeah, a clear, concise overview of what R is, why it's important, and how it works.
Precisely. Focusing on the principles and the practical relevance, how it tackles some of the big limitations we see with standard LLMs.
Okay, so let's start right there. What is retrieval-augmented generation at its core? Why all the focus?
Well, fundamentally, RA is about giving LLMs access to external knowledge when they're generating text. Standard LLMs are amazing, but they can make things up hallucinate, or their knowledge might be outdated because training data gets old.
Right.
And they aren't always great at showing their work, so to speak. RA tries to fix this by letting the model pull in relevant information from outside databases for a specific query.
So it's like giving the LLM a cheat sheet, but one that's specific to the question, and potentially much more up-to-date than its training.
That's a good way to put it, yeah. You retrieve relevant info, feed it to the LLM along with the user's question, and guide it towards a more accurate, factual, and context-aware answer. Super useful for, domain-specific knowledge or things that change rapidly.
Okay. The survey breaks down the different approaches. Let's start with the first one they mentioned, naive RA. What's the basic process there?
Right. Naive array is sort of the foundational concept. It's a three-step thing. First is indexing.
Okay.
You take your source data, text files, PDFs, web pages, whatever, and chop it up into smaller pieces, chunks.
Manageable bits.
Yeah. Then you use an embedding model to turn these chunks into vectors, basically numerical representations of their meaning.
Uh-huh.
And you store these vectors in a specialized database, a vector database, so you can search them efficiently based on semantic similarity, finding things that mean similar things, not just keyword matches.
Got it. So indexing prepares the knowledge. What happens next when a user asks something?
That's step 2, retrieval. The user's query comes in, and you do the same thing and code it into a vector using the same embedding model.
Okay, important point, same model.
Crucial. Then you search the vector database, comparing the query vector to all the chunk vectors you stored. You find the ones that are semantically closest, the top K most similar chunks.
So you're pulling out the pieces of stored information that seem most relevant to the question based on their meaning. And the final step, that involves the LLM, right?
Correct. Step 3 is generation. You take the original query, you take the relevant chunks you just retrieved, and you bundle them together into a prompt.
An augmented prompt.
Exactly. You feed this augmented prompt to the LLM. The idea is the LLM now uses both its internal knowledge and this fresh, relevant external context to craft its response.
Okay, naive Rega. Makes sense as a starting point, but the survey quickly points out it has, well, limitations. What are the main problems with this basic approach?
Yeah, it's definitely not perfect. The challenges pop up in a few places. First, in that retrieval step, you can have issues with precision and recall.
What do you mean?
Meaning you might retrieve chunks that aren't actually relevant, that's low precision, or you might miss chunks that are really important, that's low recall. It's kind of a blunt instrument sometimes.
I see. So the context fed to the LLM might be noisy or incomplete.
Exactly. And that leads to problems in the generation phase too. Even with retrieved context, the LLM might still hallucinate or generate something that ignores or contradicts the context it was given, or the answer might just drift off topic. And, biases from the LLM's original training can still creep in.
And the survey also mentioned augmentation challenges. What's that about?
That's about how well the retrieved information is actually used by the LLM. In naive RAG, the integration can be pretty basic. The LLM might struggle to smoothly weave together information from different chunks, or it might just ignore some of it. Redundancy can also be an issue if you retrieve very similar pieces of info. There isn't much fine-grained control.
Right, it's sort of just dump in the prompt.
Yeah.
Okay, so these limitations obviously led to improvements. The survey talks about advanced RAG next. How does that try to solve these problems?
Advanced RAG is really about making the whole process smarter, specifically focusing on improving the quality of what gets retrieved before it hits the LLM. It uses strategies before retrieval, pre-retrieval, and after retrieval, post-retrieval.
Okay, let's break that down. What happens in pre-retrieval, before the search?
Pre-retrieval is about optimizing both the data you're indexing and the query itself. For indexing, you might use smarter chunking, like recursive splitting, so you don't cut sentences in half, or sliding windows to keep some overlap.
Makes sense.
Adding metadata is also big: source info, dates, maybe even summaries of the chunks. This helps filter things later. And for the query, you might rewrite it using an LLM to make it clearer, or expand it to cover related concepts, or even generate a sort of ideal answer embedding, like with HiD, to guide the search better.
So cleaning up the signal from both ends, the knowledge base and the user's question, what about post-retrieval, after you've grabbed the initial set of chunks?
Post-retrieval is about refining that initial set. A key technique is re-ranking. You take the top K chunks from the initial search and reorder them, often using a more sophisticated model to put the most relevant ones right at the top.
To fight that lost in the middle problem you sometimes see with LLMs?
Exactly that. LLMs tend to pay more attention to the beginning and end of the context. Re-ranking helps put the best stuff where it's most likely to be used. Then there's also context selection and compression.
Filtering out the noise?
Yeah, basically filtering out redundant or less relevant chunks, or even compressing the remaining ones to just the key sentences or facts, trying to give the LLM a cleaner, more focused context to work with.
Okay, advanced RAG adds quite a bit of sophistication. The survey then moves to modular RAG. What's the big idea there? Sounds like building blocks.
That's a great way to think about it. Modular RAG is about flexibility and customization. Instead of one fixed pipeline, you have specialized modules like Lego bricks for different functions. You can swap them in and out or chain them together in different ways depending on the specific task or data.
Interesting. What kinds of new modules are we talking about?
Well, there's a dedicated search module that can tap into things like web search or SQL databases directly. There's HarshFusion, which tackles tricky queries by generating multiple variations, searching for all of them, and then merging the results intelligently.
Oh, neat.
A memory module lets the system remember past interactions to give more contextually relevant answers over a longer conversation. Routing modules can look at a query and decide, hey, this one should go to the technical docs, or this needs a web search.
So,
There are also predict modules that might try to generate context using the LLM itself, and task adapters to really fine-tune the whole process for a specific job, like maybe retrieving certain types of prompts or tuning the retriever just for legal document analysis, for instance.
that sounds incredibly flexible. The survey also mentions new patterns within this modular approach.
Yeah, those patterns just show how you can combine these modules, like rewrite, retrieve, read, use an LLM to improve the query before you search. Or generate read, where the LLM tries to answer first, then uses retrieval to check or enhance its answer.
Mhm.
There's also hybrid retrieval, mixing keyword and semantic search, and iterative or recursive strategies, doing multiple rounds of retrieval and generation. It's all about orchestrating these modules effectively.
It definitely paints a picture of RAGO evolving from a simple recipe to a much more sophisticated toolkit. Before we dive deeper into the tech, how does R compare to, say, fine-tuning an LLM or just getting better at prompt engineering?
Good question. Prompt engineering is all about crafting the input to get the best out of the existing model. No changes to the model or external data. Fine-tuning does change the model, training it further on specific data to embed that knowledge internally.
Right.
RBrogue is different because it brings in external knowledge at inference time, dynamically. Its big strengths are handling rapidly changing information because you just update the external database, and providing source attribution. You can often point to the document the answer came from.
Which is great for trust and verification.
Exactly. Fine-tuning is slower to update and less transparent.
Yeah.
RA might add a bit of latency because of the retrieval step, but the survey suggests it often beats unsupervised fine-tuning for getting facts right, especially new facts.
That's a key takeaway. Okay, let's get into the nitty-gritty technologies. Retrieval sources and granularity. What are the options beyond just text documents?
Yeah, it started with text, but now RAG is used with semi-structured data, like tables inside PDFs, which need special handling, and increasingly structured data like knowledge graphs. KGs are powerful because they represent relationships explicitly, but they take effort to create.
And granularity, you mentioned chunks before, but are there other sizes?
Oh yeah, granularity is about the size of the thing you retrieve. It could be tiny, like a phrase, or even a token, or sentence, a proposition, which is like a single factual statement, a paragraph-sized chunk, or even a whole document. For KGs, it might be an entity, a relationship triplet, or a whole subgraph.
And the choice matters.
Hugely. Smaller units, like propositions, can be very precise but might lack context. Bigger chunks give more context but might bring in irrelevant fluff. There's a trade-off. Some systems like DenseX focus on propositions, others like small to big retrieve sentences but add surrounding context for the LLM.
Okay, let's talk indexing optimization. We mentioned smarter chunking. What else helps make the knowledge base better for retrieval?
Metadata is huge. Attaching things like page numbers, dates, authors helps filter searches. But you can also create artificial metadata, like generate summaries for each chunk, or even generate hypothetical questions that a chunk would be a good answer for. That's called reverse ID.
Interesting. Pre-calculating potential matches.
Exactly. And then there's structural indexing. Instead of just a flat list of chunks, you might organize them hierarchically or use a knowledge graph that spans multiple documents to understand relationships between concepts across the whole corpus, like the KGP approach. This can make retrieval much more efficient and context-aware.
Makes sense. Now, on the other side, query optimization. Why not just use the user's raw query?
Well, user queries can be kind of vague or complex or ambiguous, right? So optimizing the query before search helps a lot. We mentioned query expansion, generating multiple related queries using an LLM multi-query, or breaking down a big question into smaller ones, subquery. Then there's query transformation. This could be rewriting the query entirely using an LLM, maybe a specialized one like RRR or BQE for tricky long-tail questions, or using Heidi, generating that hypothetical document embedding we talked about, or step-back prompting, where you ask the LLM for more general concepts behind the specific question to guide retrieval.
And routing.
Yeah, query routing is about sending the query to the right place. Maybe route it to a specific part of the knowledge base based on metadata, or send it to a different RAG pipeline altogether, depending on what the query seems to be about.
Lots of ways to refine the search. Underneath all this semantic search is the embedding technique. What's key here?
Embeddings are absolutely fundamental. You need models that turn text into meaningful vectors. There are older sparse methods like BM25 based on keywords, and newer dense methods, usually transformer-based like BERT and its successors. The survey mentions Angie, Voyage, BDE as recent strong ones, often tracked on leaderboards like MTE.
Dense models capture more meaning.
Generally, yes, but often the best results come from hybrid retrieval, combining sparse and dense methods. They catch different kinds of relevance. But maybe the most critical thing is fine-tuning the embedding model itself.
Why fine-tune it?
Because a general-purpose embedding model might not understand the specific nuances of your domain, like medical terms or legal jargon. Fine-tuning on your specific data helps align the embeddings with your content and task. There are various techniques for this, like LSR, Promptigator, even using reward signals from the main LLM embedder, or methods like replug.
What if you can't easily fine-tune these big models, maybe because you only have API access? The survey mentions adapters.
Exactly. Adapters are like small plugin modules, UPRISE, AAR, PRCA, BGM, PKG are some examples mentioned. You can train just these lightweight adapters on your task data to help steer the pre-trained embedding model or even the LLM without having to retrain the whole thing. It's a more resource-efficient way to get some specialization.
Okay, we've retrieved some good stuff, hopefully. Now back to the generation phase. How do we make sure the LLM uses this context well?
Right. Context curation is key. We touched on re-ranking, putting the best stuff first to avoid that lost in the middle issue. Models like BERT or specialized re-rankers, even the main LLM can do this.
And compression.
And context selection or compression. This is about trimming the fat. Maybe using a smaller language model like Long LM Lingua to intelligently remove less important tokens, or using dedicated extractor models like PRCA or Recomp, or even having the LLM critique the retrieve docs first and filter out bad ones like the chatlaw example. The idea is a clean, concise, relevant context.
Can we also tune the LLM itself to be better at RAG?
Absolutely. LM fine-tuning is still valuable within a RAG system. You can fine-tune it specifically on your domain knowledge to help it understand the retrieved context better, or tune it to generate answers in a specific format or style, or even fine-tune it to handle structured data retrieved by RAG, like the SANA framework does.
You can align it better
Yeah, using reinforcement learning to align its outputs more closely with human preferences or maybe with the retriever's judgments. And there's also coordinated fine-tuning, training the retriever and the generator together so they learn to work better as a team, like the REDIT approach using KL divergence.
Okay, the survey also describes more dynamic retrieval processes. What's iterative retrieval?
Iterative retrieval is basically doing multiple rounds of search. You start with the query, generate a bit of the answer, then use that generated text to form a new query to retrieve more information and repeat.
So it builds up knowledge as it goes.
Potentially, yes. It can make the answers more robust. But the risk is that the searches might drift off topic or you accumulate noise. Systems like ITER-Rechen try to manage the synergy better.
How does that differ from recursive retrieval? Sounds similar.
Recursive retrieval also involves multiple steps, but the focus is more on refining the query based on previous search results. It's like drilling down. If a query is complex, you might retrieve some initial info, use that to ask a more specific follow-up question, and retrieve again.
Ah, okay. Deeper dives.
Exactly. Techniques like IRQ use chain of thought prompting for this, or TOSI builds a sort of clarification tree. It's particularly useful with structured data like knowledge graphs, where you might need multiple hops to find the answer.
And finally, adaptive retrieval. What's adapting here?
Here, the LLM adapts. It gets to decide when and what to retrieve during generation. Models like Flare or Self-Reg learn to predict if they need more information at a certain point.
So the LLM calls for help when needed.
Pretty much. Self-RAG uses special tokens like a retrieve token that the model can generate to trigger a search. It might also have critic tokens to evaluate the retrieved info. It makes retrieval more efficient, only searching when necessary.
Very clever. Okay, evaluation. Super important. How do we know if a RAG system is actually working well?
Yeah, evaluation is critical. Traditionally, people looked at performance on the final task question answering accuracy, EM, F1, dialogue quality, BLEU, Regie, etc. And those still matter.
But RAG adds new dimensions to evaluate.
Definitely. You need to look specifically at the RE components. The survey highlights 3 key quality scores. Context relevance, did we retrieve good stuff? Answer faithfulness, does the answer stick to the retrieved facts? And answer relevance, does the answer actually address the query?
Right, you need all 3.
And beyond those scores, there are 4 essential abilities to assess. Noise robustness, how well does it handle irrelevant retrieved info? Negative rejection, can it say I don't know if the answer isn't in the context? Information integration, can it synthesize info from multiple documents? And counterfactual robustness, how does it handle potentially wrong info in the context?
Are there standard ways to measure these benchmarks or tools?
Yes, the field is developing them. There are specific benchmarks like RGB, recall, and KeyRE designed to test these ARG aspects, particularly robustness. And automated tools like RAGERS, ARIES, and Trillins are emerging. They often use powerful LLMs to assess things like faithfulness and relevance automatically, giving you quantitative scores.
That's helpful for development.
Okay, looking ahead, there's this big debate, RAB versus just using LLMs with massive context windows, right? What's the take?
Yeah, that's a hot topic. With models handling hundreds of thousands, even millions of tokens, you could just feed them whole books. Why bother retrieving?
Right.
But RABG likely still has its place. For one, inference speed processing a few relevant chunks is usually faster than chewing through a million tokens. Second, verifiability RGA lets you point to the source documents. Third, some knowledge bases are just too big even for the largest context windows.
So they complement each other.
Probably. And people are now researching how RAG can work best with these super long contexts, maybe retrieving larger passages or structuring the interaction differently. It's an evolving relationship.
What about RAG robustness? Dealing with noisy or bad retrieved information. That's a huge challenge for real-world use. If the retriever pulls garbage, the generator might output garbage. Research is focused on better filtering, re-ranking, and teaching the LLM to be more critical of the context. Interestingly, some studies found that sometimes a bit of irrelevant info can paradoxically help accuracy, which is weird and shows we don't fully understand the integration process yet.
Complex interactions. And you mentioned hybrid approaches earlier, mixing ARG and fine-tuning.
Yes, that's a strong trend. Finding the best way to combine them, maybe fine-tune first, then use ARG, or alternate, or train them jointly is key. Also, using smaller, specialized models within the RAG pipeline, like the CRAG example that uses a small model just to evaluate retrieved docs.
What about scaling laws? Do bigger models always mean better ARG?
We don't fully know yet. LLM scaling laws are pretty well studied, but how they apply when you add a retriever component, which might be much smaller, is less clear. Some initial work, like Retro++, is looking into it. There's even speculation about inverse scaling in some R tasks, where smaller might sometimes be better, more research needed there.
And for folks trying to actually build and deploy these things, what are the big production challenges?
Oh, plenty. Retrieval efficiency at scale, searching billions of documents quickly. Ensuring good recall, not missing the needle in the haystack. Data security and privacy controlling access, preventing leaks through generated text. The ecosystem is growing fast, though, with frameworks like LangChain and Llama Index, plus more specialized tools and cloud offerings popping up. The trend seems to be towards more customizable, simpler to deploy, and specialized ARBJ solutions.
Finally, the survey looks beyond text to multimodal R. What does that involve?
Yeah, this is really exciting. Extending RAG to handle images, audio, video, code. Models like RACM3 or BLT work with images. Others like GSS or Vid2Sic handle video audio. And things like RBPS or Coke augment code generation.
So retrieving relevant images or code snippets.
Exactly. Imagine asking a question about a diagram and having the system retrieve and understand the relevant visual parts. Or asking for code and getting relevant snippets from a library. It opens up tons of possibilities, but also big challenges in indexing and combining info across modalities.
Wow, okay. That was a really thorough tour of Retrieval-Augmented Generation.
Sure.
Just to quickly recap the journey, we went from the basic naive RAG through the refinements of advanced RAG to the flexible modular RAG.
We cover the core tech indexing, retrieval, embeddings, generation adjustments, looked at dynamic approaches like iterative and adaptive retrieval, and stressed the importance of evaluation beyond just task accuracy.
And we touched on the future, the interplay with long contexts, the need for robustness, hybrid approaches, and the expansion into multimodal data.
Right. The key takeaway is how RAG helps ground LLMs in external knowledge, making them potentially more factual, up-to-date, and trustworthy. Understanding these moving parts is pretty vital for anyone building AI applications today.
Absolutely. For all our listeners in ML data science and tech, we hope this deep dive gave you a solid framework for understanding RGE, the concepts, the methods, why it matters. Hopefully you can see ways to apply these ideas in your own work.
And maybe think about the research and tools we mentioned if you want to go deeper.
And as a final thought to leave you with, building on that RGE versus long context discussion, as both LLM context windows and RGE techniques keep getting better, how do you think the optimal balance between relying on internal model knowledge versus external retrieve knowledge will shift for different kinds of tasks? Where's the sweet spot going to be?
That's the million-dollar question, isn't it? Something we'll all be figuring out.
Definitely something to ponder. Thank you for joining us for this deep dive into Retrieval-Augmented Generation.
Thank you. It was a great discussion.